Good afternoon, everyone. Today we are going to talk about the presentation on advanced power system analysis and control. Our unit coordinator is Edward Palmer, and I am Sagar Rimal. My team members are Asmita Upadhyay and Uday Ranjitkar. Uh, Today we are going to talk about these outlines. These are aims and objectives of our projects, introduction of the project, NER clauses associated with our addition of a new generation on the grid, as well as storage option for the thermal plant we designed, and the simulation result from PSCC, as well as problem and mitigation that arises due to the connection of generation on the grid, conclusion and recommendation for those outcomes, and Gantt chart of the entire project. The main aim of our project is to investigate the issues that arises due to the connection of large thermal plant on the grid, and to determine the suitable sites for the storage of those power during the peak load period, on night or at the evening. The 550 megawatt solar power plant is to be added on the grid of New South Wales and Queensland by the simulation of PSCC on through Victoria and South Australia. The highest power generated from such thermal plant is to be stored for the peak load period. So the storage option has been discussed on our project. We discuss about the storage option from batteries, pump storage, as well as molten salt storage system, and CCT were calculated for the exciter tuning, so as to make the whole entire system to be stable for the transmission of power. And various NER clauses were discussed in order to meet the requirement of Australian electricity clauses. Among them, these are the few clauses. The partial load rejection deals with the stability of the system, so that it can against this stability after 30% load rejection within 10 seconds of the instability. Similarly, voltage and reactive power control. The exciter are tuned in such a way that the settling time is 2.5 seconds after the instability, as well as reactive power capability. The voltage at the connection point should not vary more than 10% of the nominal voltage. Similarly, protection of generating unit from power. Generating units should be protected as soon as the fault arises, so that the entire system can be stable. Thank you. I would like to call my colleague Asmita Upadhyay for the further discussion on our presentation.
Thank you, Sagar. Now I'm Asmita Upadhyay. I would like to discuss about the solar thermal and solar PV used in our project. First of all, I'd like to talk about solar thermal. Solar thermal energy, it directly uses the sunlight to run an engine. It uses the energy in the form of molten salt, and also it directly generates the alternating current. However, solar PV changes the sunlight into electrical power directly, and it uses the battery as a form of solar energy. And it needs the inverter to convert to AC, whereas solar thermal directly generates alternating current. And coming to the solar PV, it is only effective during daytime, whereas solar thermal is also effective at the night time as well as daytime. And solar thermal increases the system inertia, and it increases the economics and dispatching ability of the system. Similarly, in our project, we have used 3 storage options. One is molten salt, second one is batteries, and the pump storage. In molten salt, it is very inert and non-toxic in nature, so it is very effective. Whereas It generates more power than conventional PV plant. And coming to batteries, it stores the energy during daylight for the using in the peak hours, whereas pump storage is used for higher efficiency of the generation, and it can also be used during the offload to pump water for running the turbine during peak hour. And while doing our project, we have designed the SLD diagram before and after the generation. So this figure indicates the SLD diagram before adding the generator, and this SLD diagram indicates after addition of generator, which is added here in the QNIT. And here is the CCT results of our project. This one is the QNIT before adding the generation, where the system shows CCT is stable at this point at 0.32 second, and this figure indicates the QNIT CCT after adding the generation. And comparing both the two figures, we can see that there isn't the adverse effect of adding the generation in the system. And this is the table of CCT of QNIT and QNIT South before adding the generation, where we can see in 0.3 second, and the system is unstable for QNIT, and the system is stable for QNIT South, and for both the cases, both are stable at 0.3 second. Now I'd like to hand over to Uday for the next part. Thank you.
Thank you, Smita, for your part. Introducing myself, I'm Uday Ranjitka. Now I'll be talking about how our system get affected by adding the new 550 megawatt of solar thermal plant. So there are both positive and negative impacts on the existing grid after adding the new generation system. So talking about the positive impact, the solar thermal plant, it increases the inertia of the grid system compared to the solar PV. And moreover, the solar thermal also decreases the harmonics, flickers, and the system unbalance also. And about the negative impacts, the addition of the new generation may increase the instability of the system, as there may be the load unbalance, which will cause the instability. And also it may be quite difficult to synchronize the system at the starting of its phase. And to mitigate those negative impacts, the steps that can be taken is that the exciter tuning should be tuned finely, so that there will be less flicker, harmonics, and system unbalance. And also for the same goal, the power system stabilizer can also be used. So as a conclusion of the project, the generator that we planned satisfied all the clauses and rules of national electricity rules, and also all the aspects before and after adding addition of the new generation to the grid system was also reviewed. So as a recommendation, we were quite unable to tune the governor of the generator, so it would be more better if the governor of the generator could be tuned finely. So this one is the final Gantt chart for our project. Thank you.